Hello everyone, welcome to Royal Chem Planet. In this session, I am going to explain NEET 2024 detailed solutions for a chemistry paper. Now let us see first question. Arrange the following elements in increasing order of electronegativity. So nitrogen, oxygen, fluorine, carbon, silicon. Choose the correct answer from the options given below. So here they have given the elements, that is nitrogen, oxygen, fluorine, carbon and silicon. Now let us arrange these elements according to the order in the periodic table. So according to periodic table, we have first we have carbon, after that nitrogen, after that oxygen and fluorine. So in the downside of this carbon, we have silica. Okay. So as we know that the electronegativity of an element will be increases from left to right. So here this is the order from left to right. So from top to bottom there is a decrease in electronegativity. Okay. So here, so in the left side we have most electronegative atom, that is fluorine. So oxygen, which is lesser electronegative than fluorine. So nitrogen, which is lesser electronegative than nitrogen, sorry, oxygen. So this carbon, which is less electronegative than nitrogen. So I will write the order as, so fluorine is greater than remaining all. So oxygen, nitrogen and carbon. So here this silicon, which is in the bottom side of this carbon. So top to bottom there is a decrease in electronegativity. So this silicon will be having less electronegative than carbon. So here the correct order is silicon is less than, carbon is less than, nitrogen is less than, oxygen is less than fluorine. So the correct option is option 1. So that is silicon is lesser than, carbon is lesser than, nitrogen is lesser than, oxygen is lesser than fluorine. So the correct option is 1. Okay. So now let us move on to our next question. Identify the correct reagents that would bring about the following transformation. So here they have given alkene. So the and the product is aldehyde. Okay. Now in order to this conversion, so in order to get this product, so from this reactant, so what are the reagents that we are using? So first of all, if you consider this option 1, so here H2O by H plus, that means acidic hydrolysis. So that means hydration will take place. So during this hydration, so there is a addition of this OH at this carbon, so which means secondary alcohol. So on oxidation with chromic oxide, which gives the ketone. So this is not the correct option. Now let us take second option. So here on hydroboration, so it gives organoborane. So I will write it here. CH2, CH double bond CH2 on boration, hydroboration. So you will get CH2, 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 BH2. Okay. So now this organoborane will react with the 2 moles of other reactant, that is another 2 moles of this reactant. So you will get, so 2 moles of CH2, CH double bond CH2. So it gives trialkyl borane. It gives trialkyl borane. So this is thrice. Okay. So this trialkyl borane on treatment with this hydrogen peroxide in presence of base, which gives the alcohol, which is a primary alcohol. Okay, which is a primary alcohol. So H2O2 in presence of basic medium. So you will be getting CH2, CH, this is CH2, 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 OH. So 3 moles of alcohol. This is primary alcohol. Now on treatment with PCC, so pyridinium chlorochromate, which is a oxidizing agent. So this primary alcohol will be converted into aldehyde. Okay. So now you will get the product, that is CH2, CH2, CHO. So which is this product. Okay. So if you consider this option 2, so in the third step we have KMnO4, which is a more strong oxidizing agent, so which gives carboxylic acid. So instead of giving aldehyde, it gives the carboxylic acid. Okay. So in this case, so we have secondary alcohol on treatment with H2O in presence of acidic medium. So this secondary alcohol gives the ketone in the presence of PCC. So the correct option is option 2. So which is BH3 H2O2 in presence of basic medium and PCC, pyridinium chlorochromate. So is it clear, all of you? Is it clear? So now let us move on to next question. So here the compound that will undergo SN1 reaction with the fastest rate. The intermediate which are formed in this SN1 reaction is carbocation. So we can observe that there will be a formation of carbocation intermediate in this SN1 mechanism. Okay. Now if the stability of the that intermediate will be increases, the rate of SN1 mechanism will be increases. So first of all, let us try to understand so which intermediate will be formed. So by considering each and every option. Okay. So here if you consider this option, so in this you will get the intermediate. So by loss of Br minus in the step 1, so you will get primary carbocation, which is CH2 plus. Okay, so this is the carbocation. Okay, so here if you consider this option, so you will get this carbocation, which is a secondary carbocation. So here it is a primary, so here it is a secondary carbocation. I will take this as 1, this is 2, and here if you take this one, so here you will be getting phenylenium cation. So this phenylenium cation, so I will take it as 3, and here if you take this, so you will get the carbocation like this. So this is my carbocation, so I will take it as 4. Now if you consider all these 4 carbocations, so this carbocation is more stable because of resonance stabilization, so which is look like a allylic benzylic carbocation. Okay, so due to resonance, so it will be more stable. Okay, now when coming to this one, so it is a primary carbocation, it is a secondary carbocation. As we know that secondary carbocation is more stable than primary carbocation. Okay, so this is the less stable carbocation. So if you follow the order, so fourth one is more stable. So this is the stability. So stability order. So stability order. So that is 4 is greater than, so 2 is greater than, 1 is greater than 3. So it means the most stable carbocation is this one. Okay. So here, so this will participate in SN1 reaction very fast. So because of stable carbocation. So the correct option is 4. Is it clear, all of you? So for the reaction, 2A is gives rise to B plus C. Kc is equal to 4 into 10 power minus 3 at given time. The composition of reaction mixer is A, concentration of A is equal to concentration of B is equal to concentration of C is equal to 2 into 10 power minus 3. Then which of the following is correct? So here in this one, they have given the reaction, that is 2A is gives rise to B plus C. So here 2A is gives rise to B plus C. Okay. So Kc, which is nothing but, so equilibrium constant. So that is given by, so 4 into 10 power minus 3. Okay, so concentration of A, B, C will be given as 2 into 10 power minus 3 moles. So you have to find out whether this reaction will be in forward direction or backward direction or in equilibrium. So in order to find out that, you have to correlate this equilibrium constant with the reaction quotient, that is QC. So here, where QC is equal to the concentration of the products, so concentration of the products by, so concentration of the reactants. So concentration of the reactants. So here in this reaction, reactants are 2A and products are B plus C. So here QC is equal to concentration of B into concentration of C by, so concentration of product, that is A to the power 2. Okay, so you know that the concentration of A, B, C can be given as 2 into 10 power minus 3. So I will substitute that. So QC is equal to, so 2 into 10 power minus 3 into, so 2 into 10 power minus 3 by 2 into 10 power minus 3 whole square. So these two will be cancelled out. So I will write it as square. So square will be cancelled out. It will be 1. Okay. So this QC value will be 1. Okay. So here Kc is equal to 4 into 10 power minus 3, which is lesser than Qc. Okay. So here Qc is greater than Kc. So reaction quotient is greater than equilibrium constant. So here this reaction will be backward reaction. So backward direction. So if QC is lesser than Kc, if that is the case, so what will be the reaction? Okay, so if QC is lesser than Kc, that reaction will be forward direction. That reaction will be forward direction. Okay, so that reaction will be forward direction. Okay, if QC is equal to Kc, so that reaction will be equilibrium. So that reaction will be in equilibrium. So here, so QC is greater than Kc, which means backward direction. So this reaction has tendency to go backward direction. So the correct option is 3. So this is my correct option. Okay, so is it clear, all of you? So this is based on the QC value and Kc value. If QC is greater than Kc, that reaction will be backward direction. So that reaction will has tendency to backward direction, to go backward direction. Okay. Now, the highest number of helium atoms in. So option A, 4 moles of helium. Option B, 4 units of 4U of helium. So option C, that is 4 grams of helium. Option D, 2.271098 liters of helium at STP. Okay, so as we know that 1 mole of substance, so 1 mole of substance will be having Avogadro number of atoms. Okay, so as we already know that, so 1 mole of substance will be having 1 Avogadro number of atoms. So as we know, Avogadro number is 6.023 into 10 power 23. Okay, so here in option 1, they have given 4 moles. So 4 moles means, so 4 into Avogadro number. Okay, 4 into 6.023 into 10 power 23 atoms. So 4 units. So 4U. So 4U means 1 helium. So 1 molecule, 1 atom. So that is 1 atom. So 1 atom. Okay. So 4 grams of helium. So 4 grams means, so that is 1 mole. 4 grams means 1 mole. So 1 mole means it is 1 Avogadro number. So it is 1 Avogadro number. You take this 2.271098 liters. Okay, as we know that at STP, at STP condition, so 1 mole equal to 22.711098 liters. Okay, so here they have given 2.271098 liters. It means it is nearly 0.1 mole. It is nearly 0.1 mole. Means it is a 1/10th part of this Avogadro number, which is a less than this 4 into Avogadro number. Okay. So here, so more number of helium atoms that are present in this 4 moles of helium. That means option 1, that is 4 moles of helium is the correct answer. So this is my correct answer. So this option 1 is the correct answer. Okay, is it clear all of you? Is it clear? Match the list 1 and list 2. So here in the list 1 they have given process. So list 2 they have given conditions. So let us see. Isothermal process. So isothermal process is a process in which it carried out at constant temperature. Okay. So isothermal process will be carried out at constant temperature. So that means A is 2. Okay. So isochoric process. Isochoric process. Isochoric process is a process. It is carried out at constant volume. At constant volume. Okay. That means B is 3. Okay. So isobaric process. Isobaric process will be carried out in at the constant pressure. So that is C is 4. Okay. So adiabatic process means there is no exchange of heat will be takes place during that process. So that means D is 1. D is 1. Okay. So A3, B3, sorry, A2, B3, C4, D1. So option 4 is the correct answer. The energy of an electron in ground state N is equal to 1 for helium plus ion is minus X joules. Then that for an electron in N is equal to 2 state for beryllium plus 2 ion is ion in joules is. So here they have given energy of the ground state at N is equal to 1 for helium. So that is minus X. As we know that energy is equal to, so energy of the ground state helium can be written as minus 13.6 into Z square by N square joules. Okay, so I will write it for this helium. Okay, so I will write it for this helium. So here helium plus is equal to minus 13.6 Z for helium is 2 square by N for helium they have given 1 square joules. Okay, so here minus 13.6 into 4. So it is equal to the minus X joules. Okay. Now for beryllium plus 3, they are asking for beryllium plus 3. So for beryllium plus 3 minus 13.6 into Z value for this beryllium is 4 square by N value they have given 2. So 2 square. Okay, so this and this square will be cancelled out. So you will get same value, that is minus X joules. Okay, so it means the correct option is minus X joules. So this is my correct option. Match the list 1 and the list 2. So in the list 1 they have given molecule, and list 2 a type of bonds between carbon-carbon atoms. Okay. Now, So first of all, that is ethane. So ethane. So ethane. So in this ethane, so we have hydrogen, hydrogen, hydrogen. Okay. So here all the bonds are sigma bonds. So sigma bond, sigma bond. So ethane will be having one sigma bond. So one as sigma bond. Okay. So here ethene. So here A is 3. Okay. Next one is ethene. So ethene. So in ethene, we have C double bond C and CH bonds. So it means one sigma bond, and one pi bond. Okay. So one sigma bond and one pi bond. Okay. So here B is 4. So B is 4. Okay. So carbon molecule. So C2. So in C2, according to MOT, we have 2 pi bonds. So 2 pi bonds. So in C2 molecule, we have 2 pi bonds. So it means C will be 2. Okay. So ethyne. So in ethyne, we have C triple bond C. So here we have 2 sigma bonds, sorry, 2 pi bonds and 1 sigma bond. So 1 sigma bond and 2 pi bonds. Okay. So here D is 1. So D is 1. Okay. So A3, B4, C2, D1. Okay. A3, B4, C2, D1. So option 3 is the correct option. So this option 3 is the correct one. In the list 1, they have given compounds. List 2, they have given shape or geometry. Okay. So let us take first one. So that is NH3. So NH3. So in NH3, this nitrogen will be having total 5 valency electrons. So in its 5 valency electrons, 3 of the electrons will be involved with bonding with hydrogen. So one will be lone pair. So it means 3 bond pairs plus 1 lone pair. So here we have sp3 hybridization. So because of this lone pair, so it will be exist as trigonal pyramidal. So trigonal pyramidal. So it means this NH3 will be exist as trigonal pyramidal. Okay. So next one BRF5. So it means A is 1. So BRF5. In BRF5, this bromine will be having total 7 electrons. So total 7 electrons. Okay. So in this 7 electrons, so 5 of the electrons will be involved in bonding with the fluorine. So here we have 5 fluorines, 1 lone pair. Okay. So it means, so 5 bond pairs and 1 lone pair. Okay. So total 6. So it will be sp3d2 hybridization. So because of this 1 lone pair, it will be exist as square pyramidal structure. Square pyramidal. Square pyramidal. Okay. So this BRF5 is square pyramidal. So that means B is 4. Okay. XeF4, xenon tetrafluoride. So XeF4. So XeF4. So in this xenon, we have total 8 electrons. So out of 8 electrons, 4 electrons will be involved with bonding with fluorines. So we have 2 lone pairs. So 4 bond pairs plus 2 lone pairs. So it is also sp3d2 hybridization. Because of these 2 lone pairs, it will be exist as square planar. Square planar. So this C will be 2. So C2. Okay. So SF6. SF6. So sulfur will be having 6 electrons in its valency shell. So all the 6 electrons will be involved in bonding with 6 fluorine atoms. Okay. So it is So it is sp3 d2 hybridization, which is octahedral structure. So d3. So d3. Okay. So a1 b4 c2 d3. So a1 b4 c2 d3. So which is option 1, which is a correct answer. Correct answer. So is it clear, all of you? The E naught value for the Mn plus 3 by Mn plus 2 couple is more positive than that of chromium plus 3 by chromium plus 2 or Fe plus 3 by Fe plus 2 due to change of. So here Mn plus 3 will be converting into Mn plus 2. Mn plus 3 is converting into Mn plus 2. Okay. So in this Mn plus 3, so we have number of d electrons, that is d4. There are total 4 electrons in the d orbital. Okay. In Mn plus 2, we have d5, which is the 5 electrons in its valency shell, that is in d orbital. Okay. So this is the half-filled configuration, which is a stable configuration. So because of stability of this d electron configuration, so it will more tendency to convert Mn plus 3 to plus 2 by accepting electron. Now, if you see this chromium, so this chromium plus 3 will be converting into chromium plus 2. Okay, so in this chromium plus 3, we have D3 electronic configuration. In this chromium plus 2, we have D4, which is not a stable electronic configuration in the both the cases. If you see iron plus 3 to iron plus 2, iron plus 3 to iron plus 2. So in this iron plus 3, we have D5. In this plus 2, we have D6. Okay. So this D6 is a less stable. Okay. So that here we have the more value of E naught for this manganese plus 3 to plus 2 because of attaining stability by getting half-filled d orbital configuration. Okay, so that d4 to d5 configuration. This is the reason why Mn plus 3, Mn plus 2 couple is more positive than chromium plus 3 plus 2 or iron plus 3 plus 2. Okay. So the correct option is option 3, that is d4 to d5 configuration. Which of the following equilibrium Kp and Kc are not equal? So here Kp and Kc, what will be the relationship between this Kp and Kc? So here Kp is equal to Kc into RT to the power delta Ng. Okay. So here Kp is equal to Kc into RT to the power delta Ng. Okay. So if the value of delta Ng is nothing but it is a change in number of moles reactants from reactants to products. So delta Ng can be written as, so number of moles of products minus number of moles of reactants. Okay. So if delta Ng value will be equal to 0, so that means RT to the power 0, it means this value will become 1. So at that case, Kp is equal to Kc. So if delta Ng value is not equal to 0, so Kp is not equal to Kc. Is it clear? Now let us check out this delta Ng value for each and every reaction. So if you take this first reaction, that is PCl5 is gives rise to PCl3 plus Cl2. So here we have 1 mole of reactant and 2 moles of products. So delta Ng for this is, delta Ng is equal to 2 minus 1, that is 1. Okay. So for this second reaction, that is reactants are 2 molecules, products are 2 molecules. So 2 minus 2, that is 0. For this one, So CO plus H2O is gives rise to CO2 plus H2. So 2 moles of reactants, 2 moles of products. So again 2 minus 2 is equal to 0. So here also 2 moles of reactants, 2 moles of products. So again 2 minus 2 is equal to 0. So for this option 2, 3, 4, we have 0 value of delta Ng, which is gives the, so Kp value equal to Kc. So whereas in the first reaction we have 1. So it means it does not equal. Okay. So this Kp is not equal to Kc for this reaction 1. So it means the correct option is 1. So this is the correct option. Among the 16 group elements, which one does not show -2 oxidation state? Okay. So here they have given 16th group elements, that is oxygen, selenium, tellurium, polonium. So from top to bottom, there is a increase in metallic character. So metallic character will be increases. Okay. So if the metallic character increases, so the tendency to exhibit -2 oxidation state, minus oxidation will be decreases. It means, so if the metallic character increases, the positive oxidation state will be increases. So here all these oxygen, selenium, toluene will exhibit -2 oxidation state, but this polonium will exhibit only +2 and +4 oxidation state because of the metallic character. So which is a bottom side of the periodic table, this element which is in bottom side of the periodic table, which exhibit metallic character, so that it will exhibit +2 and +4 oxidation states. So it does not exhibit -2 oxidation state. Okay, so the correct option is 4. So this fourth option is the correct option. Okay, now let us move on to next question. Now, spin-only magnetic moment is same for the which of the following ions? So here titanium +3, chromium +2, manganese +2, iron +2, scandium +3. Okay, so in order to get this, so you have to know what will be the spin-only magnetic moment. Only magnetic moment, that is mu spin, is equal to √n into n plus 2. So this is the formula for spin-only magnetic moment. Okay. Now, where n is the number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. Okay. Now let us see which species having same number of unpaired electrons. If the species having same number of unpaired electrons, they are having same magnetic moment, that is spin only magnetic moment. Okay, now let us check it. So titanium. Okay, so we have 3d2 4s2. So in titanium +3, we have 3d1. So only one unpaired electron. Only one unpaired electron. Next, chromium. So 3d5 4s1. So in chromium +2, we have 3d4. We have 4 unpaired electrons. So Mn, manganese, we have 3d5 4s2. So manganese +2. So manganese +2, Mn +2, which is having 3d5, having 5 unpaired electrons. Okay, so iron +2. So that means iron. So in iron 3d6 4s2. So in iron +2, we have 3d6, which is having 4 unpaired electrons. So if you want to know about this, so here we have 6 electrons in the d orbital. So these are the 5 electrons and 6th electron in the 1 orbital. So 1 orbital will be containing 2 electrons, remaining 4 will be containing 4 unpaired electrons. So we have 4 unpaired electrons in Fe plus 2. So now when coming to scandium, so we have 3d1, 4s2. So in scandium plus 3, we have d0, no unpaired electron. So no unpaired electron. Okay. So it means, so this chromium, this chromium and this iron which is having, so that means chromium plus 2, iron plus 2 will be having same number of unpaired electrons, so that they will exhibit same magnetic moment, that is spin only magnetic moment. So here chromium plus 2 and iron plus 2 is the correct option. So option A, that is B and D only. So this is the correct option. So a compound with molecular formula C6H14 has 2 tertiary carbons. Its IUPAC name is. So here they have given molecular formula C6H14 and that should be contain 2 tertiary carbons. Find out this. So here N-hexane. So if you see this N-hexane, so we have CH3, CH2, 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 CH3. So all the carbons are primary carbons. Okay. So 2-methyl pentane. So here CH3, CH, CH3, CH2, CH2, CH3. So 2-methyl pentane. So which is having total 1 tertiary carbon. Okay. Next one is 2,3 dimethyl butane. So 2,3 dimethyl butane, CH3, 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 CH3. So here we have 2 tertiary carbons. So here this is 1 tertiary carbon, this is another tertiary carbon. Here we have only 1 tertiary carbon. So here 2 tertiary carbons are present in this compound. Okay. So in the next option 2,2 dimethyl butane. CH3, 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 CH2, CH3. So here there is no tertiary hydrogen. So no tertiary carbon. So they are asking 2 tertiary carbons. Which of the following compound containing 2 tertiary carbons with molecular formula, that is C6H14? So the correct option is 2,3 dimethyl butane, that is option 3. So this is the correct option. So is it clear?